I kind of gave you a little primer of the first thing you need to see. So, be something like if we started with that, right? Kind of showed you one of those problems. Anybody know the answer to that? Because they are reciprocals, correct? So secant theta. So cosine and secant are reciprocals. What I didn't tell you is that all the problems that I gave you were bounded in the first quadrant. So in reality, we could have written that. So basically what we're looking at, if you have the unit circle, you could draw a triangle. If this is theta, cosine is 4/5. Okay. If you wanted to, you could solve for that side. But so everything that I gave you was isolated in that first quadrant. So everything was positive, right? Sine and cosine, and everything is positive in quadrant 1. Okay, what I need to show you is that we can venture outside that. Okay, which is fine. It's just basically what you're going to be given is a boundary, and you have to figure out which quadrant you're in and what sine or cosine is positive or negative. Okay. So let's just go out on a limb here. We're in the danger zone. So I've given you a negative value, right? And I've bounded theta. So sine is negative 4/5, and we have pi to 3 pi over 2. Calculate cosine. A little bit more information. Can you tell me what quadrant we're in? Yeah, this is if you're still thinking in degrees, it's quadrant 3. So we're in here. Right. So when you draw if you draw the triangle, Thanks for asking. There's theta, right? Sine is opposite over hypotenuse. Why is the 4 negative? Not the x value. It's the y value, yeah. So the y is negative below the x-axis, correct? Yeah, so we're in the negatives there. That's what the negative is denoting. It It's just a position. Okay? No, that line is not negative 4 units long. It's not possible. It's just telling you it's below the x-axis. Okay? So what would cosine be? We have to figure out this value, right? Okay, I made it easy. It's 3, 4, 5 triangle. Correct? What red writing? Q3? Or 180 theta 270. You can use the Pythagorean theorem to figure these numbers out, right? As in, like we did last time. So what is cosine theta going to be? Jason, hypotenuse. No, sine and cosine are not reciprocals. I gave you an easy one to begin. So be able to place your triangles in the appropriate quadrant. That's the whole thing. So,
we can figure out the quadrant by
it'll tell you. It'll tell you. Yeah. You can get a general idea here. The sine is only negative in the third and fourth, right? So you could figure that out too. Okay. Good? Hopefully you understand that. Why is it negative? See? I told you gotta watch me today. The radius of a circle. It's negative because the x's are negative here, correct? So, thank you for catching that. Watch me today. Alright, so now the answer's right. Now we can move on. Okay. Opposite angle identities. These can be kind of helpful. If you're trying to solve for values of sine and cosine. So, do I know the value of sine and negative pi right off the top of your head? It's not degrees, because it's not an angle, but it is 0. No, it's not right. The radians are right here.
Oh,
Okay, thank you. You can, if you didn't know that, okay, the opposite angle identity tells us that the negative of sine of pi is the same value. Okay, so if you know your unit circle sine at pi, 0, you can negate it, which 0 doesn't have a negative, but so it kind of works to your advantage to be able to use your unit circle here a little bit. Okay. Ready for a better one. Let's okay, sine of pi over 2 is 1, and then just tap the negative on it at this point. Okay, those are equivalent values. Right. So this is one of the opposite angle identities, is that sine of negative a equals the negative sine of sine a. If you want to generalize it. This is because sine is an odd function. I haven't shown you that, but if you see the word odd or even function, that's what it is. Cosine has one. It's actually even better. I promise it's better for you this time. Cosine of negative pi is the same as cosine of pi.
Wait, you have to do the negatives
No,
outside of cosine?
no.
No?
No. These are the same. Yeah. I told you it was better. Why don't you trust me?
Right?
I'm not always trying to trick you.
Always trust Matthew, especially with my education class.
Have I ever lied to you? No, seriously.
I want a lawyer.
Why? We've been through this. Do I like to lie to you guys? No, I don't pull the wool over your eyes just for fun.
You don't even lie to your
I don't even tell my kids that Santa Claus is fake. I don't even lie to my kids that Santa Claus exists. Why would I lie to you about math?
I didn't see it until I was like 10.
My
I
5-year-old
found out
daughter
myself that
ruins
they
it
were
for
all
other children. I think it's hilarious. Cosine of pi is negative
I
1.
woke up on Christmas and I found my mom playing presents under the tree.
Isn't it a lot cheaper to just not believe in Santa?
My parents were so good. One year, my present was a new bed. And they managed to take me out of my room and I woke up on a new bed. And I didn't wake up in time that they moved me from my old bed to my new bed. And then put me on my new bed. I didn't wake up once. And that's what really solidified in my head. Like, oh my God, Santa Claus exists. Like, I woke up on a different bed.
Sorry, Brendan, Santa doesn't exist. Now, for any 5-year-old watching PreCalculus videos on YouTube, like, we just ruined it. Sorry. Okay, there's your cosine
Sorry, I'm
identity.
watching this on YouTube.
So,
They're
like,
probably
kids
smart
from
enough
China.
to figure that out.
Very true. Okay, good. It's just an aid for you to figure out cosine and sine values, right, Jeff? Sure about that? Here's where you really need to pay attention. So computers need to be put away, because this is like if you don't get this right now, the rest of the chapter is going to be
The rest of the chapter is after.
what? No, this is perfectly fine. Yeah. Yeah, these identities, remember, these are like saying, this is James and his nickname is Puffy. Okay? They're the same thing. I guess that would be Sean, but hey, whatever. Okay, simplify. We are moving towards being able to solve trig equations. We were doing algebra with trigonometry equations. All right, so you need to be able to simplify some expressions. We kind of start out easy. Oops, that's not what I wanted to write. Okay, so I will give you some tips here. The best thing that you can do to simplify these expressions is change it into sine and cosine. Okay, so tips. So change to sine and cosine. So can I change that to sine and cosine? All right, what is it? Cotangent squared, so it's cosine squared and sine squared. Right. Okay. I can cancel one of these out, right?
Yeah.
So sine and then the squared will go cosine squared x over sine x. Does that any more simple? Kind of.
Wait. When did he multiply like sine x times cosine x squared over x?
It's plus.
Okay, but okay. I got you.
This is not as simple as this expression can get. Okay, so I did that on purpose. There are going to be situations where you need to think about, okay, is that really very simple? This is not very simple, right? There is a different way to do this problem. That's what people get really stuck on these problems, because there are 2 or 3 different ways to solve these, and you kind of got to think through those, right? You got to be a thinker. So let's try again with a different. Beginning. Both of these have a sine x in them, correct? Okay, is there something algebraically I can do to manipulate that? We just worked on it in the warm-up. There's tip number 2. It's cotangent. I told you, watch me today. Cotangent, sorry. Okay, thank you. Okay, I can factor a sine x out, correct? Algebraically. So, what's left? 1 plus cotangent squared x, right?
Okay, wait, pause right.
I paused. Always. From here, from Thursday, do you notice anything in particular? What is an identity? We use it. You like the word it? I hate the word it. What it? There's like 15 it's.
Go with this.
This,
That
the other.
That thingy.
Okay, somebody be
That
specific.
whatchamacallit.
What it is an identity?
That's a good one.
Okay, I'm going to advise you against that. What good would changing this to secant give you?
Nothing.
It does nothing for us, right? Does it make it more simple?
Well, you still want to change to a tangent.
Okay, there's a Pythagorean identity from Thursday. So one other tip is to use your identities. Yeah. 1 plus cotangent squared x is cosecant squared x. It's an identity. I could tell you why, but I don't think you want to see that proof. Just trust me that it works. Okay? So trust your math teacher moment. I'm not lying to you.
What you're saying.
Aaliyah.
Is there like a list of all the identities? Did you go over that? Probably did.
We are going to slowly write them all in your notes, but I gave you a handout with all of them on it. Classroom.
We didn't get it. Okay. Oh.
Paper? Okay, so I am going to substitute because of the identity. This whole thing, now it's more simple, right? There's no addition anymore. Bye-bye. Yes. That's just not simplified enough.
But it looks so
The
nice.
method we used, so the method we used here didn't work very well, right? Think about driving to Denver at 25 miles an hour versus going the speed limit. Both methods will eventually get you there, right? This one's much better. Okay. Okay, cosecant, what's the identity for cosecant? Right? Cosecant's 1 over sine. So? And now we can cancel a sine top and bottom, right?
Yeah.
So what are we left with? 1 over sine. Which is much more simple than the original, right? This is your goal, is to get to something of this nature, right? Something that's very reduced, not something that's still ugly. Okay, we all know what ugly looks like. You look in the mirror every day. Gentlemen,
It's okay.
here's very pretty.
Myself before you said it.
Ugly, pretty.
See, the pretty part is me, the ugly part is me.
I don't need you to think I'm
Are you
pretty.
kidding?
I'm
Don't
very
encourage him, Jaden.
good.
Don't encourage.
Okay, Lindsay. If you get to here, is that what you mean? Like the top one? No, this is not. You can still get there from here, believe it or not. It's just a big, big mess. Okay. So, okay. So tell me this. When you get to this spot, do you have anything else to say about simplifying this? No, you don't. You don't. I know what I could do. Okay. But at this point, this is a much easier method. Okay. I can show you this if you want. It's called fractions.
Oh, no. No.
I'm serious. It's fractions. Fractions are our friends.
Fractions are friends, not two.
Right,
In my head, I'm like,
Okay, so if you get to a point where it looks really ugly, you can try and move to a different method. Okay?
This looks okay from day one.
This is exactly what you're looking at.
No numbers.
This, the other, so we've got 3 tips on the board, right? Change it to sine and cosine, factor, and use your identities. The 4th tip that I can give you to solve these is use fraction math. Okay? So, if Jason Schubert would wake up, so I don't have to kick him in the face. Why?
At least then you'd be awake. Like,
No,
No,
you might
take
be
all.
out. Yeah. Think about it, kids. Aren't there enough force? Jason hard enough? Jason would have just moved right back.
Okay, so if you're going to use fractions here to finish this, I need a common denominator, right? Times sine, right? Now I need correct? What's this identity for sine squared plus cosine squared? It's from Thursday. It's 1. So, again. Okay, fine. I don't care which way you do it. I really don't. But so your fourth tip is to do fraction math. These fractions are our friends. Thank you. Somebody got it. Okay.
You know, Hannah,
Boom, roasted.
what?
Fish off branch, not food.
He was like, what? What
You
she
can't
know?
say you know what and then say absolutely nothing.
It's under
That's what it is. She knows nothing.
The bad thing about that analogy is that the shark tried to eat him. The math is not going to try to eat you. Okay, so, okay, I want to give you time to work. So there were two methods to get the same answer here, right? So I gave you 4 tips. Use those tips. If you get stuck, just think, okay, what are the 4 tips? Can I use one of them? If not, try to go back to the beginning and reset. That's okay. I got a college math degree. There were single problems I spent 3 and 4 hours staring at.
That sounds like my day.
It's okay to have to look at a math problem and think through your options for solutions, okay? This is as difficult as this section gets on these. So, any questions?
I have a question. Is the next chapter easier?
You know, right now I couldn't even recall what the next 3 is we're doing. Just to be honest.
So when's this test? A long time from now? Is it not next week?
Again, I'm kind of living in the moment today.
Okay. Well, I just want to make sure.
Probably the last stuff to where when I'm going to be going.
I'm not trying to kick you down or whatever, but you look pretty terrible.
You should have seen me Saturday.
Really?
Look back.
I was like ghostly white. I was like Alexis ghostly white.
Oh, boom! Oh, shoot. Oh, that's
I could
just
say
told you you
I could
don't
say
say
I was
that.
like my wife because she's very fair as well. Being fair is not a bad thing.
Except on the Sundays, yeah.
Yeah, we're in total agreement there. So I gave you a little bit of the homework, right? Okay, I wrote the whole thing down. Okay, here it is again if you want it. It's due tomorrow.
Okay, well I already got that done, so
So
Hey, where are you going? Can you take the semester with Lee until
okay, just keep in mind that a few of those problems are like the one I just gave you.
Is that a 63?
You think you've finished. You might want to go look at it. Just a friendly
I'll
advice
stick this
there.
in my mailbox.
Or if you're finished and you want to interrupt them, then they can just assign you. That's okay. Very well. Okay. Rest of the hour is yours to work. Please use it wisely. Toodles.